Enterprise Software. He currently serves as the Chief Technology Officer for Canon's Medical Health Information Technology Division, leading the technology vision and strategy. Canon Medical's innovative next-generation medical imaging platforms and clinical tools are built using modern architecture and deliver streamlined, interactive, and automated workflows with high-performance scalability and cybersecurity. So we're happy to welcome Tim. I will be handing things over to him to present. I do want to know if you have any questions throughout this Zoom webinar, feel free to use the Q&A feature that you'll see up at the top of your screen. Thank you.
I had to find the unmute. Thanks, Rochelle. All right. Today, as she said, I'm going to speak about AI and enterprise imaging. But just in case not everybody knows who we are, I'd like to start with a quick intro to Canon Medical. Of course, everybody knows Canon for our cameras and printers. But a few years ago, Canon acquired Toshiba Medical. And as a result, our brand changed to Canon. Canon Medical is a global organization focused primarily on medical imaging, from X-ray to MR and ultrasound to CT scanners. Now, our HIT division was created to focus on, as the name would suggest, healthcare information technology. Again, primarily imaging focused. We make the advanced visualization and AI software that enriches images that come out of the scanner. Multimodality PACS systems, enterprise image viewing, and enterprise image archive and integrations. So from capture to diagnosis and to storage and distribution, we cover the imaging spectrum. And this gives us a bit of a perspective. With this background, one thing that I know is that these scanners and related tools generate a lot of data. Imaging accounts for the vast majority of your overall data volume. For larger institutions, this is a petabyte scale problem with archives stretching back 5, 8, 10 years or more. So for comparison, the data that populates a single screen from an EMR is typically measured in kilobytes, while medical images themselves are much larger. So going from X-ray to MR to CT studies, the file sizes get larger and larger and larger. CT studies are only continuing to grow as same as MR as the technology improves, and especially pathology. Your image archives are huge and constantly growing. And in addition to that, radiology volumes are increasing. All this data requires a lot of processing, and this is where enterprise imaging and AI come in. So let's start with AI. 10 years ago, when you said AI, most people thought of the Matrix or the Terminator. These days, most people think of AI as ChatGPT. And generative AI, like ChatGPT, has taken the world by storm. It has a ton of uses. Some of them are kind of frivolous. As an example, our leadership team had a meeting canceled at the last minute a couple of weeks ago. And one of the attendees wrote a quick haiku to celebrate getting a little bit of time back. And everybody else on the team chimed in and on the team's chat and wrote our own haikus. And later, as we were talking about it, we found out actually none of us wrote our own haikus. We all went to ChatGPT and gave it a prompt and generated a bunch of unique and fun haikus. And so there's a lot of fun uses for ChatGPT, but we're here to talk about more serious uses of AI in general. So a lot of people think of AI as a tool to replace radiologists. Now, I don't think that. I tend to think that radiologists that use AI are the ones that are going to replace radiologists that don't. But when most people think about AI and diagnostic imaging, they're thinking about image analysis, sending images in and getting some indicator or new image back to identify an anomaly or pathology within the image data itself. There is a bit more to AI than image analysis. It can benefit the entire workflow. And you're going to need a good foundation to support it. So for all of these algorithms, in order to make that work, you're going to need to use a good foundation. We think that enterprise imaging is really a prerequisite for successful AI and, frankly, other parts of your digital transformation. You have a lot of challenges ahead if you don't build and execute a proper EI strategy and governance. So during this presentation, I'll explore the key attributes of a good foundation for AI, from consolidation to data neutrality, scalability, and then finally clinical workflow alignment. These are all needed to process that incoming flood of data. And this is backed up by the HIMSS SIM definition, which states that enterprise imaging is a set of strategies, initiatives, and workflows, ultimately covering an end-to-end perspective. Now, after you read this definition, you might think to yourselves, this sounds a lot like PACS. And you would be partially correct, but EI spans far more than a traditional PACS to incorporate all of the other imaging service lines. This is a picture taken from that same HIMSS SIM white paper that did the definition. And it describes all of the various imaging content from diagnostic, procedural, and evidence imaging to as well as clinical reporting. All of this makes up enterprise imaging. And you think about what kinds of tools are needed to manage enterprise imaging. You start with, obviously, you have to capture the images, and then you have PACS and VNA, and then enterprise viewing to display the images, integration with your EMR, exchange with other providers, your integration with all of your other tools. And then, of course, cloud and cybersecurity are going to be important. And then we finally get to artificial intelligence. Now, EI inherently supports not just radiology PACS, as I said, but cardiology and mammography. Some support even pathology, though those require specialized integrations. It also cover videos and still clips from surgery, endoscopy, ophthalmology, and dermatology. So all of these are critical to a successful EI solution, but the foundation is really that PACS and the VNA. So taking a step back, where the PACS came from, it started with your traditional proprietary monolithic architecture. Back in the day when PACS were first being created, we were just trying to get things out of film and digitize it. And the compute hardware wasn't very good 20, 30 years ago when all this started. So in order to get the best performance, vendors had to store images in really proprietary structures that could be loaded quickly from disk, and then updates were stored in a proprietary database. Now, this started in radiology, but pretty soon other service lines got on the digitization bandwagon. We ended up with a lot of proprietary systems sitting on a lot of proprietary storage. Complex data flows, poor visibility between systems, too many systems to manage, upgrade, secure, backup, etc. And then things got worse as hospital systems started acquiring one another, resulting in organizations managing multiple PACS systems of the same kind, even more data silos. This led to the creation of the vendor-neutral archive. And managing got easier. Managing all these images got easier in some ways. So while a PACS tends to focus on a single department, the vendor-neutral archive is intended to manage across departments, across vendors. So now we can share data between the systems without some crazy, unworkable web of interconnect between all of the systems, but they do each have to connect back to the VNA. You still have a synchronization challenge. Thankfully, it's not a many-to-many challenge. It's just a one-to-many. Because the PACS users need relevant priors, and they want to be able to see, for example, a radiologist looking in PACS 1, if there's images in the other PACS, because from another site or something like that, they need to be able to see those. And this only gets more complicated when you bring in AI. All of this data needs to be synchronized, transformed, and rerouted. So with this VNA, we got a baseline consolidation, all of the images in one place. But as we said, there's still a lot to deal with in terms of caching. With the right platform, you can further consolidate most of your PACS systems into an enterprise-wide cacherless PACS using DICOM Web. Now, this is a new type of protocol for medical imaging that enables high-performance web-based image transfer rather than the old formats that were created in the 90s. This high performance can be achieved direct from the archive without all of the synchronization complexity and overhead. So this is a good foundation for managing and distributing all of the images. We also need to think about governance and processing all this data. And whenever I think about governance, I'm reminded of this Spider-Man meme. Now, in the first pane, Mary Jane is worried, and she looks pretty upset. And Peter, he has to tell her the hard truth. There is no shortcut. I feel for you, Mary Jane. So for AI, consolidation is key because consistency is key. The data needs to be clean, accurate, and standardized. Now, this is important for training the data, for training new algorithms, and it's also important for running on those algorithms. And I'll give some examples of this in a little bit. AI is just as much a garbage in, garbage out proposition as any other computer program. So we need to take the time to spend making sure that the data is clean, accurate, and standardized. And so as you think about consolidation and the approach to enterprise imaging, it's that governance and AI that enables successful environment. We also need to think about how you access the data. All of this should be built on a data neutrality foundation. You own your data, not the vendor. Integration and open standards are critical because we need to leave as many future options as open to ourselves as possible. Back when all of this was created, we didn't imagine that AI would come along and the types of uses that we would have. So it's really important to be built on a data neutral foundation where you don't have proprietary infrastructure and proprietary storage. The other thing that we need to think about is performance and scalability. As we scale this out, AI really impacts the infrastructure. These algorithms can be voracious. We have an example from one customer that does about 15,000 new studies a day across 400 radiologists. One day, our on-site service engineer noticed a significant spike in processing requests overnight. After a little bit of triage and diagnosis, we determined the cause. The customer had added a new AI algorithm from another vendor, and that algorithm was pulling about 20,000 studies an hour from our VNA. Not per day, per hour. Thankfully, this occurred off hours, and our system handled the load with no impact to users. But for context, in that single hour, the system processed about 600 person days of image retrieval and transfer. This is the kind of thing that AI is going to need to handle in the future. These algorithms are going to add new loads, probably equivalent to 1,000 users, because they don't get tired, and like the Terminator, they never give up. So those are three of the baseline really critical things to do with imaging, enterprise imaging, and AI. And I get to the last, and I think, frankly, the most important one. Once you have all of the infrastructure in place, we need to make sure that the AI is aligned to the clinical workflow. So here's an example. As I said before, AI brings a lot more than just plain image analysis to the table. We can improve, scanning and reduce dose, improvement workflows, categorizing studies automatically, accelerating workflows, triage, incidental findings, and auto routing for specialist review for emergency and urgent cases, and then finally, improving patient communication. In other words, a lot more than just image analysis, but it needs to be integrated into that clinical workflow. So we really need to walk through the typical imaging workflow and see how AI can help, because we really need to minimize disruption. So here's an example of a full enterprise imaging workflow, from imaging acquisition to post-processing, optimization, and then enterprise diagnostics, interpretation, and then finally to collaboration and decisions. Each step of this workflow can be enhanced. As an example, generating improved reconstructions and enhancing image quality with lower dose. There are scanners out there that use AI to generate much improved images with lower noise. We can generate new projections, new ways of looking at the images. So instead of a CT image that's just looking at top-down slices of the body, you can take the rib cage and fold it open. A radiologist will have a much easier time, detecting a rib fracture, for example, with a tool like that than they would just scrolling through the images. We can rotate anatomy automatically. If you have a patient that's being scanned that's unconscious, they're not going to be able to hold their head straight up and down. And if they do that, the radiologist has to take time to rotate the images so that they can look at it vertically and compare the symmetry. We can automatically identify body parts and images. Again, prioritizing workflows. If you have a stroke come in and something is detected, you want that to appear right away at the top of the work list. And of course, we do have automatic image analysis, hanging protocols, even layperson-friendly reports. Clinical cockpits are an interesting idea that we've been working with in terms of being able to display not just the raw images, but additional image from the EMR, additional data from the EMR. Multidisciplinary team planning, doing a lot of automation around that, follow-up identification, and finally, clinical decision tools. So I'm going to go back and I'm going to highlight some details for just a couple of these: auto image analysis and hanging protocols. And I hope when we're done here, you'll have a much clearer picture of how we can use AI with enterprise imaging. And the first example here is AI results. Now, when imaging AI was first rolled out, each vendor had their own solution. So off to the side, you see 3 servers, each with their own web viewers attached to that. This smells an awful lot like our original PACS systems, doesn't it? History doesn't exactly repeat itself, but it sure does rhyme. Radiologists hate extra clicks, and they certainly don't want to take the time to go launch another system unless there's something really important for them. So what we really want to do is we want to take those results and embed them directly into their PACS viewers. Again, the same thing can be done by taking results and providing them automatically to other specialists directly in their workflows. So here's what this can look like with a stroke case. So we can create a hanging protocol for review of the images. Now, for those who don't know what a hanging protocol is, back in the old days of film, they would literally hang the images one by one in a certain order so that the radiologist could come in and take a look at the images in a consistent way and be able to make their diagnosis. We do the same thing today on computers. It's just all electronic. So when we create a hanging protocol for the review of the images, we can start with the original acquisition. And then I don't know if you can zoom in a little bit here, if you can see this. There are a bunch of tabs across the top. It says axial, 3D NPR, perfusion summary, maps, etc. So then we'll go through and we can see, if you look at the 3D NPR, we have projections with enhanced images. So you can see different analysis that was done on the original images. And then we can dig into some automated analysis, perfusion maps, etc., DSA. So the radiologist can scan through all of these very quickly if things are taken automatically out of the advanced visualization and automation and AI platforms and put directly into their workflows. This level of integration helps them process a lot of data in a very short amount of time, enabling them to deliver higher, faster, and high quality results. My second example kind of goes back to this hanging protocol issue, because that example that we showed worked because we had a really nice, consistent set of data. As I said, garbage in, garbage out. But one way that AI can help is automatically analyzing the data and normalizing it for you. So we can show here about how some of this dirty data can be aligned. In the example here, we've got 8 different studies that were all taken with the same basic clinical need. Now, you can see each one of these has a different number of series. The descriptions of the series are varied. The number of images per series are varied, but the end user, the radiologist, still expects everything to be displayed consistently. Now, with a basic PACS system that's just doing keyword matches, sometimes this can end up with some bad results. This is going to be challenging for the radiologist, and what they're going to have to do is spend a bunch of time finding the images that they want and dragging them out. Again, kind of like the old days of hanging the images in the right order on the light board. That's going to impact their workflow and their performance. What if we bring AI to this task? We have AI look at all of those various images, train on all of those data sets, and say, let's find the consistency. Let's look in there and understand, not just based off of the descriptions of the data, but also look at the images themselves and identify the anatomy and figure out where it should be laid out on the screen. So AI can make sense of all of the underlying meanings of these images and then lay things out perfectly. This is going to save radiologists time on every single case that they read. So I hope that helps. I just wanted to underscore, that enterprise imaging really is the best foundation for AI. The consolidation, the data neutrality, performance and scalability, and then clinical workflow alignment are critical. And if you only remember these 4 things today, remember to choose open systems. You own your own data. You need to consolidate those data silos. You can't be effective with an AI strategy if you have silos of data all over the place. You need to automate carefully and pay close attention to those clinical workflows, and then prepare for scale. That AI and automation are going to drive significant volumes. And with that, I'm open for questions. Thanks.
Hey, just for everyone on the line, I hope you enjoyed that. We'll wrap up as we wrap up questions here. Don't see any coming in yet, but there is a Q&A feature at the bottom of your screen on your toolbar, and you can type your questions in there. So we'll watch for that for a couple of minutes before we wrap up the whole session. You've got one there, Tim. Can you see it?
Yeah, with a lot of AI sending information to, I don't see the whole thing.
Robert, I think you typed half your question perhaps, but I can unmute you if you'd like to speak to it. Oh, he put the rest of it in there.
To PACS. Preventing radiology burnout. Yes. Radiology burnout. I should have probably pulled in a few slides from another presentation about that. That is a huge problem, radiology burnout, because radiologists are more and more just being put on a treadmill. They need to go from one case to the next, to the next, to the next. And really, I'll kind of go back to the same thing that I said before with all of these additional images. We need to find ways to just make their job easier, for those images to be laid out exactly like they want them, so they don't have to spend a lot of time doing various fix-ups, laying out the images in the hanging protocols, rotating the head CT of an unconscious patient, rotating that vertically so they can do the comparison, things like that. There's another thing that we have to worry about too, is that studies have shown that the quality of the reads can vary throughout the day based off of the radiologist being tired or not. Just like any of the rest of us, right? You do your best work when you're wide awake and when you're alert. And AI can really help out there, can provide some additional sort of at the end steps of, okay, here are the things that the AI found. Did you see any of that? Of course, all of that needs to be done in context, in the workflow, in order to make sure that we minimize the additional amount of time that they have to spend. It has to be a really quick step with no additional clicks, or they just won't use it because they need to get on to the next thing. I hope that answers the question.
Okay, we're watching the Q&A for a couple more minutes here. And also if folks want to directly speak or ask a question, you can raise your hand and we can take you off mute. We have to do it for you. We got a couple more come in. Do you see them,
Okay.
Tim?
Yep. Sure. Is AI used in radiology in large health systems? Absolutely. There's a fair bit of this going on right now in many of our customers. They're using it to do things like automated stroke analysis. This is something that's really improving time to care on things like that. There are a lot of AI algorithms that are automatically doing bone density analysis, doing new projections, even calcium scoring for cardiac cases. So these are things that take time to do that are fairly routine. And if we can automate all of that, that dramatically reduces cost and, again, physician fatigue. Another question here says, can I speak to how AI can affect work list prioritization? Yes, absolutely. Again, as an example, if AI finds something that looks like it might be concerning, then that can prioritize to the top of the list. There are a number of different types of AIs in medical image analysis, and the FDA has different classifications in terms of that AI, whether it's going to just identify it as something for prioritization, whether it will identify it and make a recommendation, or whether the AI will just actually deliver measurements. Each of those has an increasing level of scrutiny. Now, the first one is probably the lowest level of scrutiny, and there are quite a few things out there. So, for example, if you happen to do a chest CT scan for a various the patient's coming in for another reason, and you happen to detect an aortic aneurysm, that can be flagged as a critical issue and brought straight to the top of the list, so the radiologist looks at it right away. Same thing happens with stroke cases. Another question was, wouldn't AI be giving false positive results? And wouldn't the radiologist be relying on AI rather than their own instincts? That's a great question. And so, yes, it is possible for AI to give false positive results. The FDA does require that images not bypass the radiologist. The radiologist does have to look at the images. They shouldn't, for example, even in a stroke case, there can be early care and things like that done. But what needs to happen is the radiologist needs to sign off and read the report first before certain things progress. Same sort of thing happens with AI. And so, is it possible that some radiologists will skip through and let the AI do it? Well, maybe. I think that really depends on how you handle the workflow. If you set the AI results to be at the end of the workflow, you can use it to verify what the radiologist caught. Or if you set it at the beginning, they do have to decide whether they agree with it or not. At the end of the day, ultimately, it is the radiologist's responsibility to determine whether or not they like what the AI said as an output. There have been some AI where they found, for example, in mammography, where the AI is actually better than radiologists in some cases. And so that is an area where I think we're going to see more of that over time, but we still need that human element. Let's see, another question about the issue is under or over calling. Yeah, saying the same thing. It's the provider, ultimately, the human, responsible for a missing diagnosis, and not the AI vendor. So yes, absolutely, we need to make sure that that the humans are still in charge, But ultimately, the AI is just here to assist us and help us be better.
Okay. I don't see any other questions coming in. Oh, there's another one.
One more. Okay. Data belongs to the patient. How do we envision giving data access back to the patient if AI takes it somewhere in the cloud? Yes. That is an important thing to work out as you're working out your contracts with your vendors. A lot of the default contracts for the AI vendors are that they want to keep access to that data for a long period of time so that they can train and create new algorithms on that. That's ultimately something that's between the provider and the vendor, and frankly, patient consent is important for that. We're a global company. This is very different in other countries, and in Europe, for example, has very different laws around this than we do in the United States. What I was speaking to about the data belonging to you and not the vendors was also about in terms of how the data is stored. So if you're for your vendor neutral archive, for example, if the data is stored in proprietary formats, and the vendor might believe that that's kind of their data that they're giving you access to, and I've always said no, it is absolutely the provider and the patient's data, but you do have to work that through with your contracts and your agreements with the vendors.
Okay, don't see hands raised and I don't see Q&A. We just have to talk really slowly, Tim, because sometimes something pops up.
Yep.
But that might be all of our questions. Okay, so I'm going to call it. Thank you, Tim, so much
Okay.
for
You're
your
welcome.
presentation and the time today. This is really informative. Thank you to those that joined us today. I hope that this was beneficial for you. And we will send out a recording. Watch for it on LinkedIn and also in your email, the same email that this invite came through. So for now, thank you, everyone, and have a wonderful Memorial Day weekend.
Thanks, everybody.